Welcome to a video on continuous distributions. So to explain what a continuous random variable is, under this heading, it's a variable that can take any particular value in a particular interval. So it doesn't have to be a whole number, it can be decimals. So that's height, weight, time are good examples of that. It's a probability, or it's defined by a probability density function, and that's represented by f of x. And as the interval can be from minus infinity to positive infinity, then most of the probability that's associated with will be equal to 0. And we'll see that as we go through examples. And f of x, the probability density function, is represented as a piecewise function. So we're going to just use sort of a real life example to try and make sense of this. So we've recorded times that students are out of class in the last 10 minutes of a lesson to go to the toilet or whatever they happen to be out of class for. If the teacher wanted to know when a student went to the toilet in the last 4 minutes, well, there's 42 in the 50 to 68, 58 and 8 in the 58 to 60. That's 50 out of 200, so that's a quarter. But what if we wanted the last 3 minutes? So we could approximate, but we're going to have a look at how that operates. And that's why what PDFs actually do, and we're going to incorporate, believe it or not, integration into working this out. So firstly, we work out the probability. So that's, for the first one, the frequency was 10 out of 200. So 10 out of 200 is 0.05. The next one is 54 out of 200. And the probability adds to 1. But the relative probability, because each bracket is 2 minutes, we divide it, and it'll make sense when we actually calculate why we actually need to do this. But we divide each by 2 so that it's relative to the actual per minute. So it's 0.025 per minute. So drawing it as a histogram with the class on the bottom and the those frequencies on the side, we see that we form almost a parabola type shape, and the areas of the rectangles, if you would add them all up, would equal to 1. And we know that our rules to be a PDF is that it must be equal to 1, so that it's a probability density function. We could also use the histogram for this, and if we did the histogram, we'd also find out that the areas are equal to 1 underneath the histogram using triangles. So it does approximate the shape there. It does approximate a parabola with a turning point at the centre, which was 55, 0.215. So it's in the form of minus k x minus 55, because we've shuffled it right, the parabola right 55, and up 0.215. So firstly we'll find the value of k. So since the area under the curve must equal to 1 to be a PDF, we can actually integrate and let it equal to 1 to find the value of k. Our integral, so our table, if you remember, went from 50 to 60. So we do the integral from 50 to 60 of that equation that we formed and allow it equal to 1. And so the integral of that, so we're integrating with respect to x. So the x minus 55 squared becomes power of 3, and you divide by the power of 3, or you use the reverse chain rule and you'd end up with a third out the front. And the 0.215 integrates to x. So we're going to sub the 60 and the 50 in. So we sub the 60 in and the 50 in, and that's the equations we form. Simplifying those two brackets, so finding common terms, we end up with minus 250k over 3 equals minus 1.15, giving us a k value of 0.0138. So that forms our PDF. So this is what we're going to see regularly. We're not going to necessarily set each one up, but we're going to see that it's in the form of an FX or a PDF. So the PDF for those values go from 50 to 60. Remember, it's the X values from 50 to 60. And remember we said that our PDF can go from minus infinity to infinity, so the majority of the other values are 0. So that's where it's otherwise. Remember, our focus was on the last 3 minutes. So therefore, we're going to integrate from 57 to 60 of our new equation, substitute it in, and when you solve that, you get 0.1068, that the probability that the student's out of class in the last 3 minutes. So it can't calculate the probability that the student is out at the exact time, so the 58th minute into a lesson. Because if you did integral from 58 to 58, the upper and lower limits, they would cancel out and leave you with an answer of 0. So if x is a continuous random variable, then the probability that x equals x will always equal to 0. So, and when we think about a rectangle, the rectangle will have no width, because in the 58th minute, that is a width of 0, because it's not going between anything. It's got no width in it, and hence the area is 0. Hence we come back to our probability of x equals x would equal to 0 as well. So here's the second example where the PDF's already given to us. So the function equals a half x between 0 and 2, and it's 0 otherwise for all other values. So firstly, we're going to show it's a PDF by firstly showing that the function is greater than or equal to 0, so that was one of the other properties. Your graph must be always above the x-axis, so it must be always y values are greater than or equal to 0, or the function. And the area under the curve must equal to 1, so we're going to integrate between 0 and 2. And then we're going to find the probability that x is less than 0.4. So this function's a straight line. It goes from 0, 0 to 2, 1, so therefore it is above the x-axis. At 0, it's equal to 0 when you sub 0 in for x, and when you sub 2 in, you get 1. So therefore it is above the x-axis. You could graph it, would be another way of showing it. The area under the curve must equal to 1, so we integrate a half x between 0 and 2, and you get a quarter x squared between 0 and 2. Subbing 2 and 0 in, you get a quarter of 2 squared, which is 1, and so therefore it is a PDF. So it satisfies both conditions, which is what we need to prove. So for the second part, to find out from less than or equal to 0.4, we're going to do the integral from 0 to 0.4. So we integrate, we get a quarter x squared, subbing 0.4 minus subbing in 0, and you get 0.04. So that's a probability it's less than or equal to 0.4. So using the same one, let's find the median and the interquartile range. Okay, so we know the median is halfway, so that's 0.5. So therefore the integral between 0 and some value must equal to 0.5. So when we integrate a quarter x squared between 0 and k, we then substitute k in minus substituting 0 in, and you get k squared equals to 2. So the median is the square root of 2, because you take the square root. And because it's between, so we know it should be plus or minus the square root of 2, but because our values are between 0 and 2, it's the positive for the median. So when we're finding the interquartile range, if we want to find Q3, we're going to let the integral equal 0.75, and we want to find Q1, we're going to let the integral equal 0.25. So the same, we go from 0 to k of a half x dx equal to 0.25, that's to find Q1. So our Q1 is equal to 1 when we solve it. That equal to 0.75 is equal to the square root of 3. Meaning our IQR, which is Q3 minus Q1, is root 3 or surd 3 minus 1. So here's our fourth example. So a continuous random variable, it is a probability density function, is given by that. where C and D are constants, and we're going to find the exact values given that the median is 4. So the first thing is it's told it's a probability density function. So therefore the integral between 2 and 5 is going to equal to 1 because it satisfies a PDF. So that's the first step. The integral from 2 to 5 is equal to 1, and the median's 4. So therefore from 2 to 4, it's equal to 0.5 because the median is at 0.5. So working it with 2 to 5 of cx plus d. So if you integrate that, you get cx squared over 2 plus dx. Sub 5 and 2 in. Simplify, and we get 10.5c plus 3d equals to 1. So that's the PDF side, proving, knowing that it's the integral equals to 1. Step 2, the median is 4. The integral from 2 to 4 equals to 0.5. So integrate, sub 4 and 2 in, and you get 6c plus 2d equals 0.5. Now, hopefully you realise that if I've got to find a c and a d value, so I've got to find 2 unknowns, I'm actually going to be using simultaneous equations. So we've got a pair of simultaneous equations. We're going to double the first one, so you get 21c plus 6d equals 2, and we're going to triple the second one, so you get 18c plus 6d equals 1.5. 3c, therefore, if you subtract those, 3c equals 0.5, giving you c is 1/6 and d is minus a quarter. So for the cumulative distribution function, this is represented by the capital F of x. It's the integral of f of x within the specified domain, and it must be between 0 and 1, as a probability must be between 0 and 1. F of x is equal to 0.5 like we just shown for the median, 0.25 and 0.75 for Q1 and Q3 respectively. So show this is a PDF and hence find it's a CDF. So once again, a PDF, we need to prove that it equals to 1. So the integral of 1 over x squared, or x to the minus 2, is minus 1 over x. Minus 1 over infinity is 0, or approaches 0, so we call it 0. And minus 1 over 1, so you then subtract it, you get 1. As the graph of 1 over x squared is above the x-axis, so it's the hyperbola, but because your negative values are squared, it actually is in the first and the second quadrant, but we're obviously 1 to infinity only focusing on the first quadrant. So to find the CDF, that's the integral from 1 to some value. So we sub that in, so we go from 1 to k of 1 over x squared. So the integral is minus 1 over x, sub in k minus sub in 1, so minus 1 over k plus 1. So we're talking in terms of x. We use the k just to get a value. So the f of x, so the CDF, the capital F of x is minus 1 over x plus 1 between 1 and infinity, and is 0 otherwise. So note, if I wanted to find f of 2, I would just sub that into the equation, and f of 2 would equal to 1/2. And that represents from 1 to 2, because obviously our domain goes from 1 to infinity, so the f of 2 would be from 1 to 2. Second one, we've got a probability density function. We're going to find the value of a. So given that f of x equals a from 0 to 4 and 2a from 4 to 8, and then we're going to find an expression for the cumulative distribution. So firstly, the integral from 0 to 4 of a plus the integral from 4 to 8 of 2a, since it's a PDF, must equal to 1. So the integral of a is ax, sub in 4 minus sub in 0, and the integral of 2a is 2ax, sub in 8 minus subbing in 4. So we get 12a equals 1, so a equals a 12th. So now if we want to find an expression for the cumulative, we're going to focus on the two different ones. So we're going to focus on a from 0 to 4, where a is a 12th, and we're going to integrate a 12th. And so you get f of x equals a 12th x plus some constant. We can sub in the first value, which is when f is 0, the function is 0, so you get c 0, so you get a 12th x. Because this is the beginning. So the beginning is when f of x is 0, x is 0. from 4 to 8. So that was 2a, so 2 times a 12th is a 6, so you're integrating a 6. So we get a 6x plus c. But from our first equation, if we sub 4 into our first equation, we get a third. So therefore, f of 4 is equal to a third. So therefore, f of 4 means when x is 4, f of 4 is equal to a third. So we get f of 4 equals to a 6 times 4. F of 4 was 1/3, a 6 times 4 is 2/3, so c is minus a third. So therefore that f of x for that second one is a 6x minus a third, since we showed that c equals minus a third, giving us our cumulative distribution as f of x equals, so capital F of x equals a 12th x from 0 to 4 and a 6x minus a third from 4 to 8. Thank you.